Welcome. Thank you very much for joining us and for being here to attend one more of the NewTechAqua webinar series. Today we are organizing the webinar on feeding strategies to support fish health and to reduce the use of antimicrobials, a topic for Sparicotyle chrysophrii infection. So before we start the webinar, let me introduce you very briefly the project, the NewTechAqua project. So NewTechAqua project is a project funded under the European program Horizon 2020. It's an innovation action, meaning that the results that and the knowledge generated for the project should arrive to the industry, to the sector. The project was approved under an ambitious goal that was launched in 2018 and 19, called Sustainable European Aquaculture 4.0 Nutrition and Breeding. Under the one, 4 projects were approved. Those are efficiency, intelligent fish feeding through integration of enabling technologies and circular principle, aqua impact, genomic and nutritional innovations for genetically superior farmed fish to improve efficiency in European aquaculture, NewTechAqua, new technologies, tools and strategies for a sustainable, resilient and innovative European aquaculture, and future EU Aqua, future growth in sustainable, resilient and climate-friendly organic and conventional European aquaculture. NewTechAqua projects, which is acronym means new technologies, tools and strategies for a sustainable, resilient and innovative European aquaculture, is an innovation action that has a duration of 4 years that started in January 2020 and is finishing at the end of this year, at the end of December 2023. The project is coordinated by the University of Bologna. It comes on the participation of 25 partners, and it has a contribution of about 6 million euros and an overall budget reaching nearly 7 million euros. So the project has a high quality consortium. Among them, there are 11 research and development institutions, universities like the University of Bologna, Venice, the research centers like IRTA, HSMR, and other centers from North and Mediterranean countries. Also, there are 12 partners from the industries, from fish farm companies, from aquaculture feeding companies, from biotechnology companies, and 3 partners working on exploitation and disseminations. Those are the Federation of European Aquaculture Producers, the CIHEAM, the International Center for Advanced Mediterranean Agronomic Studies, and Green Innovate. So the strategy, the objective of NewTechAqua has been to expand and diversify aquaculture production of finfish, mollusks, and microalgae by developing and validating technological, advanced, resilient, and sustainable applications. The project has focused its research and efforts in the most important fish species produced in Europe, such as salmon, trout, sea bass, and sea bream, but has also worked in 4 important emerging new species, as the amberjack, migre, sole, and mullet, but also in 2 mollusks, oyster and mussels, and in 3 microalgae species. Those are the species the project has focused its effort, but the topics, the areas of work has covered different disciplines, like new information technology, the production of sustainable, circular, and organic feeds, the new farming technologies, the development on new produce, the advance in the domestication and reproduction of emerging species, and new aspects of breeding and genetics on fish, oysters, and microalgae. Also, NewTechAqua has made a very key effort on dissemination and training, trying to be well, to work and be sure that the knowledge generated for the project is it arrives as much, well, as many stakeholders and citizens as possible. And for that, the NewTechAqua has implemented an ambitious program through the organization of advanced courses, training workshops, e-learning modules, and this series of webinars. And the last activity that we are organizing is a school campaign. Most of these activities are organized by CIHEAM, both CIHEAM Barić and CIHEAM Zaragoza, in coordination and with contribution and collaboration of all partners for NewTechAqua. Just to give you an example, we have organized CIHEAM Zaragoza course on nutrition and feeding in the month of June in Zaragoza. And our colleagues from Barić next week are organizing a course on organic aquaculture in Tricase. It's one of the outpost sites of CIHEAM Barić. We have organized a training workshop in Spain with IRTA about low impact aquaculture farmings, and our colleagues of Barić are organizing in Venice with the University of Venice a workshop at the end of October about precision farming in aquaculture farms. So as you know, well, we are organizing a webinar series. The month of October is very intense. We are organizing 6 webinars in October. We will do one more, a final one in November. But today you are here for this webinar that we are organizing about the use of functional diets to prevent Sparicotyle infection in sea bream. At the end of, well, the middle of November, the 15th of November, the project is organizing its final conference in Brussels. To the one you are invited. Just a practical issue, letting you know how we are going to work today. We are going to start with a series of presentations. At the end of the presentations, we will have a questions at the moment for you to ask all the questions. But do not wait till the end to start writing your questions, because the presentations are going to be consecutive. But by using this tool, the questions and answer tool that you have in the menu, you can start writing your questions or doubts that the panelists, the guest speakers, may try to answer at this moment, or leave it for the end for the final discussions. So, Luca, I'm going to stop sharing. You can continue.
Yes. Okay. Okay. Thank you very much, Bernardo, and welcome and good morning to everyone. My name is Luca Parma, and I work at the University of Bologna as a fish nutritionist. And I will briefly introduce the work package 1 of NewTechAqua that is dealing with feed and feeding strategies. Within this work package, we have several objectives. The first objective was to improve fish health, reducing Sparicotyle chrysophrii infection in sea bream through the application of natural functional diet that will be presented today in the webinar. But also we promote marine byproduct valorization using innovative free catch fish meal diet in sea bass, and also towards this sustainability issue, we also develop organic low fish meal aquafeed for conventional and emerging species. And we use some tool such as microbiome application to enhance health of farm species in relation to feeding regimes. Within this work package, we work in strict collaboration with industry, feed company, and fish farming, together with University of Bologna and IRTA as a research institute. The first task was focused, as I said, on to promote the health of the fish and to fight against Sparicotyle chrysophrii infection. As in all the approach of this web package, we first conduct some testing trial and laboratory condition, and then we scale up the result at in-field trial. So this task was made in strict collaboration with the University of Bologna, Veronesi as feed industry, and Cromaris fish farm. In a task for develop sustainable diet, reducing wild caught fish meal and fish oil, we also test several diets in European sea bass at the laboratory of University of Bologna. And then the best diet and what were more promising, we have been tested in field trial with Cromaris, and all these diet have been produced at industrial scale level using an industrial approach that was one of the most important approach within this project. And similar, this was also made for the development of organic feed in sea bream, meager, and trout. In this case, it was a strict collaboration within IRIDA as a feed industry and Galaxy D Marine Farm, where the diet that had been tested in laboratory conditions were then validated in open sea cages. And these results were presented in the webinar, but are also being published on paper, and you can find this information on the NewTechAqua webinar. Today we are going to show there's the result of the NewTechAqua trial, and also to discuss this important issue related to the reduction of Sparicotyle chrysophrii infection in Mediterranean cases. That is an extremely important issue as to be combined with several actions, and the feeding strategy is of course very important in this case, to both improve the health of the animal and to reduce the spread of this parasite. As a first speaker will be a talk of Maria Letizia Fioravanti and Andrea Gustinelli from the University of Bologna. They are going to talk about Sparicotyle infection in aquaculture, making an overview of the problem. The follow speaker will be Roberto Cerri, that will talk about functional ingredient to prevent Sparicotyle chrysophrii infection, and also he will introduce the approach that we have done in this project. After that, Matko, Kolega from Cromaris will present the evaluation of functional ingredient at FARP level that have been tested within the project. And finally, I would like to thank Francesc Padrós that accepted our invitation. Francisco from the University Autónoma de Barcelona. He will make a talk on crossroads for integrative management on Sparicotyle infection. So I would like to thank you, all the speakers and all the participants, and hopefully it will be a fruitful debate and discussion at the end of the webinar. Thank you very much. And I give the floor to Maria Letizia Fioravanti and Andrea Gustinelli. Thank you.
Mm-hmm. Okay, we see your screen in the okay.
Do you see it? Yeah.
Yes, we see it well. You can go
Okay.
ahead.
Good morning. So, me and the colleague Gustinelli will share the presentation on Sparicotyle infection in aquaculture in overview. It is a huge topic because a lot of studies have been conducted on this parasite, mainly during the last decades. So we tried to synthesize the main knowledge, and we organized, okay, here you can find our beautiful pictures and the short biography, and also the contact details if you want to contact directly us in the future. And we organized this presentation in different sections. The first one will be presented by myself, and it will be like an introduction, a presentation of the parasite. So it is on the history, morphology, and life cycle and diagnostic approach. Then we have 3 sections on epidemiology, effects on the host, and the current status of treatments against Sparicotyle chrysophrii, and my colleague Gustinelli will present these sections. Just to start, let me introduce myself. I am Sparicotyle chrysophrii, so I'm not very similar to the parasite, but I like to start to introduce the parasite as a friend, just presenting the main features of the parasite, mainly as morphological and biological, and also diagnostic features. So, Sparicotyle chrysophrii, just to shortly present its relevance, is a gill parasite found in gilted sea bream, mostly in this sparid host, occasionally also in other sparid host, and reported in mainly, almost exclusively in the Mediterranean Sea. Currently, it is considered one of the most serious pathogens of farmed sea bream in the Mediterranean. So mainly in intensive farming, but also in different land-based farming in some countries. It is very well adapted to the cage environment. We will see also this particular characteristic of the parasite linked with the life cycle of the parasite. And the infection in cage environment, the cage environment, is due mainly to already parasitized fish present in the cages, but also related to infected wild fish. The infection of Sparicotyle due to Sparicotyle can cause severe gill pathology, or already at low intensities of the infection, sometimes mortalities, mainly in juveniles, but always or almost always relevant reductions of productive parameters, so of performance. So we made just an identity card of the parasite. So very short. Here you can see, okay, already here, maybe a lot of us already know very well this parasite. The typical picture of a highly infected sea bream with this typical very pale gills with the parasites which are quite big, so you can see them very, very well at the naked eye. Here at higher magnification. Here we can see at the light microscopy, and we start and here at the scanning electron microscopy. Here we can see the typical attachment organ of the parasite, which is multiple and typical because it is composed of dozens pairs of these small clams, which is typical. And then other morphological characters that you can see also better here, where we see how we can see the parasite at the microscope with the typical eggs inside the uterus of the parasite. This is a flatworm of the class Monogenea, just to give some general taxonomical detail. And as I already said, it is reported in, it is a specific of sea bream, gilded sea bream, but it has been reported also in other sparids, in particular in Diplodocus puntazzo, mainly in captivity. Its localization is only the gills of the host, where it is quite sedentary. The morphology is very, very roughly typical of a flattened flatworm. It is, the shape is elongated, as you can see, up to 5 and over 5 millimeters. So it is quite big. And it is equipped with a very high number of clams, up to 78 pairs in adults. It is hermaphrodite, oviparous, with typical eggs with long polar filaments. Hematophagous is very important for the pathology and the effects on the host it can cause. And the life cycle is direct. So it doesn't ask for intermediate host, but it is directly transmitted between fish through some infective stages which are free in the water. So I don't have the time to speak about the long history of this parasite, but I wanted to put in this presentation the references useful to go in deep with the knowledge on the history and with a wide bibliography available on this parasite. So you will find these references in our presentation. Anyway, the history started in 1863 with the first description by Van Beneden et al. Then several descriptions always in wild sea bream, of course, in the Mediterranean, in specific areas of the Mediterranean, with several morphological descriptions, and only in 1984, this microcotyle chrysophrii, as was named since the beginning, was transferred in the genus Sparicotyle. So since 1984, the name is Sparicotyle chrysophrii. So before, all the papers refer to microcotyle chrysophrii. Then a lot of studies were conducted in during the 50s and 60s and so on ecology of the parasite and the development of the parasite, also during the first phases, mainly in France, in wild sea bream always. And then other studies, but more recently, were very helpful to clarify all the development, also the ecology, the first larval stages, and the influence of biotic factors on these parasites. You can find here a selection, of course. Okay, then here you can find some reference also on papers on ecology. And then since 90s, so in particular since 1990, we find the first descriptions of Sparicotyle chrysophrii in farmed gilded sea bream all around the Mediterranean Sea, starting from Faisal and Imam, the first paper, also describing the impact of the parasite on the performance of fish, stating that also a low number of the parasites could influence the Fulton index, the condition factor of the fish. And then several papers describing in all the Mediterranean areas and also with some deep observation on epidemiology and so on. Then we have also some recent papers on the transmission and pathogenesis of the parasite. In particular, all these studies on the transmission in experimental facilities and the observation on the larval and post-larval stages during the last year allowed to define the life cycle of the parasite, which is this. So we have a direct life cycle. We have the sea bream, which is the host of the post-larva, juvenile, and adult stages of the parasite. This is a parasite living in the gills in a sedentary way. They produce eggs, filamentous eggs, as you can see in bundles, at least 20 or more eggs together. And the fact that these eggs have long filaments, cause their easy entanglement in substrates or directly in the gills of the host, or for example, in the net of the cages. So explain also this problem of the adaptation of the parasite to the cage environment. Then we have the eggs in the environment, hatching and a free swimming stage, which is the infected stage for the sea bream, the Onchomyracidium, you can see here, which is the ciliated larva. And you can find here all the particular and all of the influence, for example, of the temperature, on the incubation time, on the survival of the Onchomyracidia, and so on, which are very useful to define the life cycle, because the biology and ecology of the parasite is fundamental for prophylactic and control measures. And the references are cited here and already reported in the previous slides. So here, just to say, I wanted just to say that the life cycle is basically regulated by temperature. Temperature, in general, warm temperature, but the temperature which is close to the Mediterranean values of spring, late spring, because, for example, we have the main success of hatching between 14 and 22 degrees, for example. And here you can find another particular feature, a biological feature of the parasite, for example, very useful also to understand how to approach the prevention treatment, is that Onchomyracidia hatches mainly during the first hour of the darkness, so mainly during the dark, and so on. So you can find here some indication, but the life cycle is this one, is direct and with parasitic stages, but also environmental stages like eggs and infective stage Onchomyracidium. Then, just to close with the diagnosis, I show you some slides, then you can find also in this case some reference, some indication written in the slides. The parasite is big, so Sparicotyle, how you will find and recognize me? Quite easily, because the adults are big, the juveniles, when are approaching the adult stage, are big. So we can find them just by naked eye or just with the help of a stereo microscope. Then we have to use a light microscope at higher magnification to find developmental stages like post-larval juveniles, and to identify the parasite on the basis of morphological, here there is a video just to to see how the parasite at low magnification can be seen at the microscope with these bundles of eggs, which are eliminated, or in some cases inside the uterus. Okay, here we have some gills infected also with epitheliocystis, but you can see here some morphological characteristics like genital atrium, suckers of the oral opening, mouth opening, testicles, and so on. So,
Maria Letizia,
yes?
you might need to go a little bit faster.
Yes, I have finished my part.
Okay.
So, yes, so just here there is a very recent paper, very useful to have a picture of how post-larval stages, juveniles and adults are distributed in the different four gill arch. Very useful also for diagnostic approach, because the main thing, the main problem is to quantify the parasite. So if it is quite easy to find and recognize it, it is more difficult to define the right number, so the intensity or abundance of the parasite, which is critical to decide the intervention. So, okay, here just some images made by scanning electron microscope of the clamps constituting the attachment organ. And so I give the floor to Gustinelli, my colleague, who will speak about epidemiology and the effects on birth.
Thank you. Hello to everybody. So many of things we have already said with Letizia, so we can jump very quickly. So we can consider the Mediterranean as an endemic area for Sparicotyle, with few reports outside from the Mediterranean Sea. In the abiotic factors, there are many studies on the role of temperature in the development of the life cycle of the parasites, of Sparicotyle chrysophrii. I can underline only the optimal thermal range in which there is the most successful hatching period for eggs, that is between 14 and 22 degrees. And the biological limits are between 10 degrees and 30 degrees. Sparicotyle chrysophrii has also a big tolerance, a high tolerance to salinity, so you can find it in different environments, and it follows a specific focal period, usually with the hatching period concentrated in the first 4 hours of darkness during the day. About the risk factor, you can see this slide resume a little bit the main risk factors involved in the parasitosis, and maybe Sito will go in deep on this aspect later. Just to underline that we have to remember that all the fish stages are susceptible for Sparicotyle, but juveniles are more sensitive in this case. And the typical farming system in which Sparicotyle chrysophrii spread is sea cages, okay? But in some countries, as Letizia already said, we can find also in inland tanks some problem with Sparicotyle. So, concerning the achievement or the result of NewTechAqua, a new perspective on the epidemiology of Sparicotyle chrysophrii is to apply some model to predict the behavior of the parasite, and maybe to decide also some kind of intervention. So you can see this reference that is quite recent, is from this year, and this is a very interesting paper that I can suggest to everybody that wants to go in deep in these aspects. Concerning the effect of the host, we have already seen the main clinical symptoms and the signs of the parasites on sea bream, so we can jump very quickly. Remember that the parasitosis and the parasite give the door also to secondary infection that could have a role on the pathogenic development of the disease. Okay, so we can see nice pictures from past papers here, and we can see the clamps that clamp the tissue of the gills, and there is also some amputation. So there are lesions of the vessels, hemorrhages, and so on. Some strange results from our observation, but also from other colleagues, is that usually the inflammatory reaction around the parasite is quite low, but you can have a very high inflammatory reaction on the closest areas of the gills in this case. And this is a recent paper by Enrique and colleagues from Spain, in which the attempt was to make a score, a histological score on the cells characters, cellular characters of the lesion around the Sparicotyle. And an important achievement is that hemoglobin and hematocrit variables are affected by the parasitological action of Sparicotyle chrysophrii. Okay, and concerning the project, NewTechAqua project, our attempt is to build another additional scoring system that takes in consideration a specific criteria to give an overall aspects of the health status of the gills with Sparicotyle. And we are still going on with the reading of the slides, because there are many fish to examine. But we can say that in this case, in our opinion, but let's retry in the future also, this score could have a good potential for specialists in fish pathology. And the assessment is really a nightmare, so I hope it will be useful for all the other colleagues in the futures. It's important to standardize the gill process, because it's not an easy task. Maybe many of you can understand this aspect, but the good news from this histological score is that it could be an objective tools to evaluate in a correct way the complexity, the overall health status of the gills. Okay, and also the modular structure of the score allow to apply it also on different pathogens and different fish species in the future. This is a dissemination aspect, so we can go very quickly. Concluding with the in vitro and in vivo treatment, because there are quite many papers published now from the past, starting from the Spanish colleagues on 2006, in which the first attempt to treat the parasite with chemicals mainly has a good success with formalin, as obvious, and also with the hydrogen peroxide, and maybe Sito will discuss on this later. And they try also the Praziquantel as in vivo treatment, and they say that it could be used also for preventive treatment. This is very important, because probably in the next future we have to take in consideration also the preventive aspects more than the treatment of the parasites. And Praziquantel, you can see also in the next papers, have only one big issue, two to be honest. One is about palatability, that could be overcome with some ingredients in the feed, and also with the environmental aspects, because it has an impact on environment. So we have to evaluate very carefully this aspect to propose also to the legislative part of the aquaculture this medicine to treat Sparicotyle. So there are other trials, in vitro trials by Ivona in the Parafish Control Project, during the Parafish Control Project, published in 2021, with good results by the synthetic substances, in particular bitumen sodium, and also quite good result with the natural compounds that could be applied in combination with synthetic one in a preventive strategy, but also in a treatment strategy. So the time is running, so we can go very quickly. Other trials you can find cited here by Paolo that propose also caprylic acid as a good compound for a preventive use in a functional feed, and we will speak later in the next speech. We will talk about this. And also febendazole is very effective, just to add to praziquantel another medicine. And another recent paper by the Greek colleague says that praziquantel is the good medicine again. So we are quite sure that it works. And we have to remember that in the field, we have some reports from colleagues that try to use ivermectin against Sparicotyle chrysophrii without any proven efficacy. So the take-home message is stop to use ivermectin in the cascade mechanism in the European legislative framework, because it doesn't work very good. Okay. So let's conclude with the new approaches on the treatment of Sparicotyle, on the nutraceutical aspects, nutraceutical approach. And you can find here also, again, caprylic acid with other compounds that in a combined effect could have a good success to treat the Sparicotyle chrysophrii. And also this proposes some other compounds that could be effective on the prevalence and abundance and intensity of the parasite. And finally, I give the assist to the colleagues from NewTechAqua project, from the feed, because the functional feeds maybe in the next future will be the key strategic point to fight against this parasites. Hope it was clear. I just finished.
Okay, thank you very much, Andrea, Maria Letizia.
Okay.
So as we said before, we should continue. And thank you. So next talk is Roberto Cerri.
Yes.
So maybe let's see. No.
Okay.
Okay, it's working okay. So you can start, Roberto, please.
Okay, good morning. I'm Roberto Cerri, and I'm going to show you a presentation about the functional ingredients to prevent Sparicotyle infection. As I told you before, my name is Roberto Cerri. I'm a marine biologist, and 2 years ago I started to work in Veronesi as a product manager. Here you will find all my contact, my mail, and my mobile phone. Today's orders of business, the Veronesi's experience with the limits and the opportunities in different feeding strategies, such as the drugs as a feed, so the drugs in the feed as a vehicle of active molecules, and the feed as a cornerstone of a strategic choice in the farm management. So about the drugs, we carry out 2 series of studies with one feed, one species, Subrime, and E8 treatment in collaboration with the University of Bologna and the University of Sassari. We tested 3 pharmaceutical molecules and 2 alternative solutions with garlic, allium sativum, and caprylic acids. For the details, you will find here on the right the paper. So, and one is under review. So the positive effect of the use of drugs. So the effect on parasites is almost instantaneous. And then it's the best way, the use of the feed, so the inclusion of the drug in the feed is the best way for the administer of the drugs in the fish farm throughout the feed. But there are also negative aspects, so the limits. For example, there are few molecules that are registered in the world, and we working in Europe, we have very restrictive rules, and also ensure the chemical residue level in the fish or in the fillet are below accepted threshold in order to maintain the customer confidence in the industry, and this must be considered because it's so important. And in the recent year has been greater intention in reducing the use of the drugs, for example, the farm to fork or the Green Deal. As said before, the use of the drugs in the feed, in the pellet, have an impact on the palatability of the pellet. For example, the inclusion of the high level of the drugs have an effect on the oral administration of the feed due to the low palatability. And also the use of the drug can increase the resistance of the parasites. So for all these aspects, drugs must be used prudently and responsibly to minimize the negative impact. Also, there is an impact in the industry, in the plant. For example, when we use the drugs, in the plant means dirtying it and consequently cleaning it to avoid the cross-contamination. And this is a cost for the company, for the industry. So for all this reason, we promote a shift of the paradigm. So the use of the functional feed, the functional feed must promote the growth and health of the farming fish by improving their immune system, inducing physiological benefits, and must be economically attractive, of course, and should be environmentally friendly. In the project NewTechAqua, we tested the caprylic acid. Is known that to relieve inflammation and reduce the oxidative test. However, little is known about the effect on the gill tissue and the gill microbiome. And the researchers in the NewTechAqua are working precisely on this. So we tested also the iron and the zinc, so the trace element, which have an effect on the anemia induced by the parasites. You can see in this picture. So the trace element is required by the animal for numerous functions, such as immunity, reproduction, skin integrity, muscle development, and egg quality. So it's extremely important. Also, the vitamin B, the complex from the yeast Saccharomyces cerevisiae, has a numerous positive effects, such as the energy-yielding metabolism, maintenance of normal mucous membranes, and the red blood cell formation. In collaboration with the University of Bologna, Alessio, and Cromaris, we have created a premix for the fish industry with all these elements: iron and zinc, vitamin B, and caprylic acids. So we did two different experiments, one in the lab, where we tested 5 diets, one control diet, one with caprylic acid with 15 and 30 grams per kilo, and 2 diets with a mixed, with caprylic acid, iron, zinc, and vitamin B at with 5 kilogram per kilo and 10 gram per kilo. And then we did another trial in Cromaris where we tested the premix. So the results were presented at the symposium in Sorrento and also are presented in the next presentation. Thank you so much.
Okay, thank you very much, Roberto. So let's continue. We pass the floor to Matko, Kolega from veterinarian from Cromaris company. So Matko, you can start, and whenever you wish Luca to pass the slide, you just tell him. Okay,
Yes, yes.
please go.
Okay. If how you know, the Miss Renata Barić has urgent work today, so she asked me to replace her. So I will try to do that. I will talk about evaluation of functional ingredients at farm level. So at first I will say a few words about Renata. She is R&D manager, and you see his what she do in company, and also I will share some information about tasks of R&D development or department. Okay, as you see, the veterinary service is one part of R&D department, and also we have one small plant for trials. We have laboratories, etc. A few words. We can go on next. Yes, this is few words about Cromaris. We produce Biase, Bream, and Meager, and also we have two new species, Dentex and Amberjack. We have 7 farms, 1 hatchery, and 1 processing unit. And you see, we have some how to say certificate like IFC, SSI, Global GAP, antibiotic free, ISC of 4001, ISC of 9001. We sales last year more than 30 tons of whole fish equivalent, and most of our production is exported, mainly in Italy, but all over of Europe, and we have more than 6,000 employers. We can go now. We'll talk about feed and feeding strategy, and about our trial to control Sparicotyle chrysophrii. Okay. Look, I can go. Yes, the aim of this task is to evaluate the performance of 2 functional feeds based on caprylic acid, how we know, and other compounds by vitamins from yeast, herbal extract, essential oil, iron, zinc, and at different dosages. Benefits in the industry is we want increasing breeding performance, increasing survival rates, reducing antiparasitics bat, lowering the production cost, reducing environmental impact, animal welfare, and sustainable the business. And I will not talk about Sparicotyle chrysophrii because my Letizia talk about it. And also we heard about this functional feed, and we heard everything about that. We have two functional feeds with two different dosages, and we use this feed on our farm for trial. And we can go quickly next farm. You can see the cages. We try to have same conditions for so the potential of fish is determined by genetic background. So we try to have same influence of environment and farming practice. So genetic background of the fish neutralized by using the same fish or origin from the same hatchery and from same batch. Environment influence is neutralized by performing experiment on the same place. Also, the farming practice neutralized by performing trial on the same way. Okay, we use technology produced with the same people, so effect is will be difference in the results comes from difference in feed. So we use small cages, 955 meters, volume 225 cubic meters, and beginning initial number was 10,000 pieces per cage. Initial weight 7 grams. We have the trial was start in February and in November, so we have 10 samplings. We sample 100 pieces per cage and expect survival 18%. So final weight's about 30 grams. So in total biomass in each cage was 2,100 kilos, which mean biomass around 9 kilos per cubic meter, like in other cages in our farms. Okay, I said trial duration from February till November. We have 6 cages. We have 2 replicates. Key is mean small cage 1 and 2 are fed with feed HB05. Small cage number 5 and 6 are feed by feed HB10, and control feed is given in cage 3 and 4. And we can go next slides. We use these doses, 5 grams per kilos and 10 grams per kilos of herbs, extracts, oil, fats, caprylic acid, vitamins B and iron, zinc. Okay, we can go now. So we do every with sampling the fish, we do biometric. we measured weights and how long fish long. We took the samples of blood, fish blood, and measure of hematocrit. Also, we measure usually oxygen and temperature level, and we microscopic check the gills and the results. We have prevalence, intensity, abundance, and related gill pathology. So this is how this picture shows how we collect the samples for biometric, and we also we have put anesthesia, take the sample from blood, samples of blood, hematocrit measure, microscopic glass, and this is the samples for microbiome. Okay, this is how we do that. Remove opercle, remove the arch, and here's the chambers for histology. And now you can see the results. This is the mean weight during the trial. We start about fish with about 8 grams and finished in November almost 300 grams. We can see different bit with growth. You can see the all fish in all cases is similar weight on the end of trial. This is the prevalence of infections with Sparicotyle values during the trial. We can see on this slide that in June start the rise of prevalence, and in July was the highest of prevalence, and after that the prevalence is on same level until the end of the trial in the November. So result intensity of infection values during the trial. If you can see that we have in July how we expect the most bigger intensity, because it is connected with the rising of temperature in sea. After July, the intensity of infection is lower, and then until the trial. Also, the hematocrit values during the trials, you can see in the August we have the lowest quantity of hematocrit, because after July, where we have the biggest intensity of infection with Sparicotyle, the fish was with low hematocrit, and after that the value of hematocrit in September, October rise until the November is on same level. This slides is not our slides. The Renata put this slide, but I don't know explain this because maybe colleagues from Bologna better explain this statistical data. But finally, my results conclusion is the functional feed with 10 grams of per kilos reduce abundance of Sparicotyle by about 38%. Respect to the control feed and feed with 5 grams per kilos, and same temperature, age, and condition index. It's very good results, and we can think about using that feed in the future. And that's its end of this short
presentation. Okay, so thank you very much, Matko. So I'm sure that there are questions. There's going to be discussion about this, but let's continue. So Francesc Padrós from the Autonomous Autonomous University of Barcelona. So please.
Okay, let's try to share the presentation. Just one moment. I don't know if I am using the right one. Can you see the presentation? And let's try. And now,
yes,
it changes.
No, we see it in the working mode, not in the presentation mode.
No, because I have problems with that. I have checking again.
Mm-hmm.
So otherwise, what I can do is, one moment, is I can do it, and I can pass manually.
Okay.
Oh, now it's here. Okay. Okay, one moment. Now,
yes, it works.
Perfect.
Good.
Thank you very much. So, good morning, everyone. So, as it is said, my name is Francesc Padrós, and the topic of my presentation will be crossroads for integrative management. Maybe some of you already know me. I am based at the Autonomous University of Barcelona, and I've been work package leader in the former Perform Fish project, and I am currently also work package leader of the project Cure for Aqua. So I am not directly involved in NewTechAqua, but I think it's very important because all these projects in the last, let's say, 5-10 years, we're in contact. And you will see at the end that it is really relevant that all of us were focused in the same direction. Okay, so I will just basically start my presentation asking, well, integrative management. What does it mean? So basically, I would like to address your attention, especially for those that you have children, and especially when your children have head lices. And if you want to get rid of head lices, probably you need to take different decisions. There is not a single strategy that can be successful. Maybe you don't have children, no problem. I have other examples. If you have dogs, for example, and you have fleas, probably you are suffering this problem. And remember that, for example, in the case of dog fleas or cat fleas, remember that in the problem is not in the dog. The problem is in your furniture. Okay, so I think it's very important to take this into account because Sparicotyle strategies or Sparicotyle control strategies has a lot of similarities with that. So remember, if we ask solutions for Sparicotyle, there is not a single magic, fast, efficient, and cheap solution. Forget about that. Another important thing is that this is not a common solution for everybody. Each place should have tailor-made specific strategies. Okay, And I think it's more important, and we will address a little bit in the presentation about that, if we look Sparicotylosis as a fish diseases, but also as a pest. I think that this is a key in how we can address the control of Sparicotyle. So basically, for an integrative and holistic approach, nice words, we need tailor-made solutions. So we need to take into account that at this moment, 99% of the requests of the problems came from very local, long-time endemic cases and places. It's not just a matter that, okay, I have a new infection. No, I've been having with the infection for 10 years. Okay, I think this is important. This is nothing new. It's something that we are seeing for ages. Another, maybe not so important, is why is, as Dr. Gustinelli said, why is endemic in the Mediterranean? But for example, in other places that also produce sea bream, for example, Canary Islands and the Red Sea, for example, is not endemic yet, or will be not endemic. Maybe there are some different aspects that we should address. I think it's a question that could be important to address. And another important thing is that in this case, and for example, compare with other diseases such as pasteurellosis or other diseases by bacteria or viruses, is really not a disease associated to the transportation of juveniles, because in the different checks, juveniles are negative to this in general. There are some exceptions, especially if you are producing in a nursery in cages. So this is an exception, but in general, this is not the normal transmission. Okay. So what should we know about the disease scenario? Well, I will not insist on that. Maria Letizia and Andrea already instructed you about the main cycles, about the reality of Sparicotyle. You know how are these cycles, and the idea is that basically the problem is that because they are producing progressive fast multiplication rates and strong permanence in the system. So this is the key. They have a strong permanence in the system. So maybe we think that we know everything about the cycle, but there are some lagoons in knowledge about that. For example, we know that the cycle, and this has been nicely demonstrated by all colleagues, but recently also by Enrique Riera, on the time about between the egg hatching and the new egg hatching. It's more or less 1 month, 30 days. Okay, and it's also related to the temperature. Another very important thing that there is a huge egg load production that keeps retained in the substrates of the cage. For example, Enrique demonstrated it was a flow-through system that numbers such 12 to 25 eggs per square centimeter get retained in a mesh. It's a lot. We know that each time that an Sparicotyle adult release the eggs, there is 10 to 20 eggs that are released to the environment. But the problem is that how often do you do that? How many eggs then can lay the parasite during the life? There are changes in the fertility. It's important because it's related to eggs during the lifespan of the parasite. There are still many questions that we need to address to sort out all that, especially on eggs, because I think it's one of the hot spots on the disease. We need models, and as Dr. Gustinelli said, we started with models, very interesting models. We already have in-house data collection in farms, so this is very important. Most of the farms, they have already developed systems about data collection and scoring. Maybe we can talk later about some kind of homogenization of the system, but for sure in the future will be very important modeling the disease. This is the cycle already presented previously my colleagues, but basically I would like to split the cycle into different areas. At the right part, you see the fish compartment that we have to address the sparicotiliosis as a disease. But from the other side, we have the environmental compartment that we should address this part of the disease as a pest. And this is very, at least for me, is very important. Together with this cycle, we have this what I call the secondary cycles. Basically, the one that I think that it works are the escapees, or the sea breams that are outside of the cages, and that can act as reservoirs of the disease, because it's the same species, so no problem, because the Sparicotyle is very species specific. So this is the target species. What about with the other Sparidae? Well, there are still doubts about if other sparids they can act as a reservoirs of the disease. I really, and I'm sorry if I am a little bit strong on that, but I really don't care too much about the reservoirs, because the main reservoirs is inside the farm. So don't care about having the big problem you have inside the farm, and you cannot get you cannot get rid of. And the problem is increasing. It's like a snowball. You start with a few parasites, and in 1 year you have thousands, millions of parasites. I think this is the key of the problem. And depending on the resilience of the fish, you really know, and has been also addressed by my colleagues, juveniles are less resilient than adults. I think this is also key to understand the problem. So let's start a little bit with the fish. So we know that the adults, but also the juveniles and the post larvae are based in the fish gills. So against that, what we can do? Basically, we can have two different kind of approaches. First one is a therapeutic treatment. We can do by bath treatments or by oral treatments. We will develop this later on, and we can have what we call the non-medicinal approach. Okay, with the other ideas. Remember that this is not therapeutic. We are not talking here about medicines. Basically, we have a nutraceutical approach that has been nicely developed by Roberto. And also, I think it's important to have this approach to increase the genetic resilience of the fish. This is another strategy that can be used for integrative management. Remember, as I said, that the impacts are different in juveniles or adults. For example, the same number of parasites in a juvenile has much more effects than in an adult. So the main target of sensitivity is between 2 grams, that is the earliest wave that in some places sea bream fry are immersed in the cages, till more or less 150 grams. That is, let's say, the most sensitive period on effects of the parasite. This is also important to assess if this is the first attack, the first time that the fish is parasited, is affected by the parasite, or has been in touch for 1 year, has been in contact with the parasite for at least 1 year. That is more or less 1 year is the time that more or less the fish are in the cages. So it is important also to face the adaptive response, especially of the biggest fish, from 200 grams to half kilo or even 1 kilo. Okay. The impacts are also different in different moments and situations. For example, winter versus summer is not the same fish in winter that, for example, normally has very low hematocrit. So in these cases, if you have a bloodsucker, then you can have higher effects. So normally, in some cases, big mortalities are observed vaguely in winter. So we also have to focus that. And also in front of other demanding husbandry processes. I think it's not the same to deal with Sparicotyle in a farm at low intensity conditions that at high intensity conditions. Okay, I think it's something that is important also to be aware. Concerning the environment, so we move from the fish and we go back to the environment. Look at the eggs and the Onchomycetidia. Basically, this is, as I say, is the key. So the strategy is remove as much eggs as possible. This is key. Okay, and we can say, okay, and what happens with the attachment of the eggs to the gills and the direct reinfection? Well, comparatively with the attachment in the cage structures, this is very low. And also, it is important to bring in mind the possibilities to do a management based with Onchomycetidia. That is also a possibility. Okay. So concerning the environment, the non-medicinal strategies and the role of the production systems and the production areas. Why the disease is mainly expressed in sea cages and not so much in other systems like flow through, although it is possible, okay, or inland extensive systems, RAS. Why? Basically, I think it's there are two reasons: a better clearance in these systems and the batch isolation. There are other aspects that can help to reduce the expression of the infection in sea cages. But basically, at least from my point of view, these are the two main reasons. And as I said, why is it so different expression of disease in the Mediterranean and in other places? For example, Canary Islands. Some people say, okay, in Canary Islands you have rough currents, water currents. Okay, this can be a point. Okay, the Red Sea, they also have a strong water currents. The water temperature is higher, maybe is limiting even the Sparicotyle, because sometimes temperatures are 28, 29. So maybe it's a limit for the parasite itself, not for the sea bream, because it can become adapted to high temperatures. All these aspects are in the floor and can be also discussed. Which tools we have and which tools we can use to manage the disease? Basically, we can have as treatments, as treatments, we have something very simple that sometimes is not addressed. For example, fresh water. This has been done in other diseases, in other species. For example, salmon. It is known that natural fresh water can reduce the embryonic development, even can detach the parasite. The sea bream has some kind of acceptable tolerance to low salinity ranges, 5%. But I don't know why fresh water has been not very much considered as a possibility. Maybe because we are in the Mediterranean environment and a source of large volume of fresh water is not easy to reach unless you are close to a river or you have specific reservoirs. So there are some examples in salmon, for example, in Australia, in Tasmania, that the fresh water can be a possibility. Just to put on the floor, and at least, for example, for cases that you have a certain capacity to work with fresh water, and I think this is something that you can at least test. Well, let's go to the formalin. Andrea already informed you about formalin. There is a single commercial product available in some countries in Europe. There is disparity between countries about the legal use of this substance, that this is registered as medicine. That is important. It's not a disinfectant, it's as a medicine. And basically, you know how can be the use in cages. Basically, the protocol is always the same. So first one, I will see that in the next slide, in the following slides, is the diagnostic. It's very important to score the level of infection, scoring how is the fish stock status, and then to take a decision. Then you know that it's not so easy. It's just not to put a drop of formalin in the cage. There is a very complex logistics, very specific procedures for single cage treatment, sometimes problems with the water temperature, problems especially when you want to treat at high temperature, that can be a problem with mortalities. the biomass to treat, the limits of time for fish concentration, the water quality and oxygen supply, welfare issues, the requirement for materials, ships, and personnel, because you need a lot of people to do a single bath with tarpaulins in a cage. So we don't have time to expand on that, but it's not so easy to perform a bath treatment, as most of you already know. In ponds or in tanks is easier. Here we have just to assess the water quality, the organic matter, and the oxygen. So in this case, it's much more easy to apply a formalin treatment. And we have other options. Okay, for example, what happened with oxygen peroxide? I receive comments from colleagues that they say they have a very weak efficacy results, and especially problems at high temperatures. Be very careful when using oxygen peroxide at high temperatures, because can kill all your stock. Other possibilities, maybe sodium percarbonate that release also oxygen peroxide, maybe for tanks, for ponds. Let's see what can happen with peracetic, because peracetic has acceptable results for other monogenes, especially in freshwater. Remember, the chemistry in marine water is completely different. So let's see how reacts the peracetic in salt water. And Praziquantel. Here I am talking about bath. In some places they use Praziquantel, but because of the cost of Praziquantel, you can use only Praziquantel in bath in small tanks, because it's very expensive. Remember that oxygen peroxide is a non-medicinal disinfectant, so it is possible to use in fish. And the second case, Praziquantel is clearly a medicine. About oral treatments, as it was also said by Dr. Gustinelli, we have basically two molecules. I am talking about medicines again. It's not about other substances. Praziquantel, febendazole, and other benzimidazoles. Here I would like to focus not on palatability, but on other problems. The first problem is that there is no specific commercial products license for fish. This is one of the problems. We can prescribe with cascade on off-label, but this is exceptional. We cannot use this as a routine. There are issues about the legal use of these substances in the different countries. So the approach in Spain is not the same in Italy, or in Croatia, or in Greece, or in Turkey. And there will be stronger regulations in the future about the use of medicines, especially in safety, residues in the fish, residues impact in the environment, the cost, because really it's very expensive. If the pharmaceutical industry will be willing to invest in a specific formulation for fish or not. Basically, I don't see a very let's say a colorful horizon for that. I see more or less a dark horizon for the future for the use of oral treatments as medicines, as I say. Okay, I'm sorry. There is here, if you are interested, there is a recent paper of Praziquantel recently published. If you are interested, this is the reference. Basically, to summarize, there is also a couple of papers recently published about the first one on general sparicotyliosis, and another paper on specific antiparasitic. So part of this information is already published in this other paper about antiparasitic approaches in Mediterranean marine finfish farming. Let's go to the non-medicinal compounds and the nutraceutical approach. I will not say anything about that because Roberto did it very nicely. Basically, the idea is to test the capacity of organic compounds like cetral, camphor, others, or garlic extracts, short meat chain fatty acid, that in fact is one of the strategies already tested, caprylic acid, or other substances. So I think this is a very nice, let's say, path to develop this kind of nutraceutical approach. So I will not insist on that. Here you have the best specialist on that. So you can address the questions to them. Maybe the only questions that we can have, I don't know, is single compound, combination of different compounds, additional technology in pellets or extruded feeds, the delivery pattern, regularly feeding in 3 days. Well, I think it's part of your know-how, and you are developing that. So I think probably you can address to the farmers exactly how should be the most efficient way to deliver these products. Also, it's important to adapt the strategies to each farm. For example, something that is very important is this nutraceutical approach works when you have still low impact in the farms. Doesn't work when you have a huge impact in the farms. Don't expect magic solutions. If you want to go to nutraceutical approach, look on that. Look on the intensity. Look on the prevalence, because it can work or it cannot work if you have a lot of parasites. Okay. Or do it, for example, as I will suggest at the end, after synchronic treatments. I think would be a good strategy. Treat synchronically many cages in the shortest time as possible, and then you can implement this strategy once the number of parasites has been reduced. Here you have better chance to have better results with nutraceutics, not before, because the number of parasites will be too high. And the modulation of the disease through the control. Well, just to say something about, for example, lufenuron, that you know that at low dose, they reduce the hatching rate in arthropods. I am not talking here about monogeneans, okay? Remember that also lufenuron is a medicine treatment, okay? But okay, there is any alternative of producing any kind of egg disruptor for monogeneans? Is maybe this one of the strategies of the success of the caprylic acid? And here I put you, I think it's an old paper, but it's very interesting because analyzes a little bit how is it's very, not simple, but it's, I think it's many years ago, it's 73, you can imagine. So, but it's also addressing the possibility how the monogenes, they form the eggshell, and maybe I think here it can come ideas about strategies about to reduce the hatching rate or the viability of these eggs. Just think on that. Genetics. Recently, we were lucky and we had some research about the genetic selection in Medate and perform fish. There is a very nice paper on that. The problem is that has a low the heritability of the residents is low. This is the bad news. A moderately favorable genetic correlation, okay, and something similar was also found, for example, for diplectanum in perform fish. So I think for monogeneans, I don't see much excellent opportunities for genetic selection. You can do something about that, but the current results doesn't support that the genetic selection could be really relevant in the strategies to control Sparicotyle. As I said, for the environmental management, the strategies remove as much eggs as possible. Remember that the eggs they attach to the substrates using some kind of a Velcro style to the microfilaments, and the microfilaments is the most the harsh part, especially if you are talking about artificial substrates. For example, in the cage nets, all the multifilament exposures, especially after the abrasion, for example, failure, fatigue, break, fraying of the ropes of the nets is the perfect scenario for the attachment of the eggs. And the natural one, biofouling. So this is the two combination, all cages together with biofouling. This is the best scenario for the attachment of the eggs. Okay, so if you go with a strategy to avoid that, probably you will have success. Higher net damage means higher opportunity to attach. Then solutions. You see that, for example, now there are some robots and some machinery that are developing to clean the nets. This could be a good possibility, but the question is, if you are using this kind of cleaning robots and you are removing the eggs from the nets, then the eggs stay here, or it is better the traditional system that you are removing the net, you are changing the net, you are cleaning the net, disinfecting the net inland. I think the second one is clearly much more efficient to remove the eggs. So I think it's also important to take into account when you decide which cleaning system you will use in your farm. By onchomericidea, we know that after hatching they have only 24 hours to do a trip to the fish. So what are the factors that facilitate the success of the new attachment? Basically, the presence of high numbers of eggs around the same cage, but also remember from the neighbor cages, it's not a problem, the same cage. Probably there are cages that are so close that they can do the trip from the cage of your side. So they are onchomericidea are very good in short and mid-distance trips. Remember that. The fish density in the cage. The more fish that you have, the more probability will have the onchomericidea to attach to the fish. This is crystal clear. Lower water currents, they will promote probably the attachment. The night hatch and the night watch, the negative phototropism. There is any possibilities to use, for example, light to attract and to pump the onchomericidea and to remove the onchomericidea? Is this kind of what I call the fatal attraction to light. We can use this in favor of us. There are other possibilities to use some kind of onchomericidea deterrent. Maybe this is also the nutraceutical approach has some implication of the production of some kind of onchomericidal deterrent substances, some kind of signal quenching, or as I said, we can think about the possibility to produce traps for onchomericidea. Also, let's think about that. So for the integration of these tools and the strategies, I think it is very important to have, first of all, an accurate diagnostic, then a holistic approach, the multiple battlefronts. The more battlefronts you put, the better results you will have, and think about the synergic effect of this holistic approach. If you put many measures all together, there will be always a synergic effect of these measures. So concerning the accuracy, be sure that it's only Sparicotyle. It's not a problem related to a gill disease complex. Are there co-infections? Okay. Sometimes Sparicotyle is not the only one in the problem. There can be co-infections that in the gills or a systemic. Is a single culprit. I think it's very important because in many cases we have combined infections with other meringians, with epithelial-assisted other diseases. So in the scoring system adopted in NewTechAqua, you also address to that. It's very important to know that you have exactly only Sparicotyle, or there is some friends together with them, especially, for example, with tenativaculum that is frequently found together with the necrotic lesions that are inflammatory lesions that cause the parasite. How much the infection burden, parasite load, intensity, score. Find a common system. We have a very good example in AGD with the scoring system. It is used worldwide, in Norway, in Chile, in Canada, in Australia. I think it's very important to develop, let's say, a standardized system for the assessment. How? I will not. Do you have a specialist? I think it's something that we have to debate. Remember also the differential impacts in different fish populations and the economic impact. Okay, money is important also. I think it's not only a question of how much it costs that. Okay. Where important, remember that it's a problem basically in cages, but think about other possible situations. How long is the same problem detected for 10 years or is something new. It's very important to understand the dynamics of the disease. So finally, we go to the last part, and let's go for integrated solutions. Okay, so are you fed up with your miserable life? So basically, change your lifestyle. So you see, eat the balanced diet, nutraceutic approach, okay? But what happened with the Sparicotyle? So you are fed up with continuous problems in the Sparicotyle? I think something that is very important, and I know that it causes pain. You need to change your production system, and they will tell this how much time as necessary. Avoid the perpetual parasite cycle, permanence, and feedbacking from neighbor cages or farms. To have this system with many cages so close, and even worse, to have 3-4 companies operating in the same areas, this is a nightmare. Believe me, you cannot get rid of Sparicotyle. You are still following the same strategies. I know that that the situation, there is no spaces. I know that, but if you not change the system, you cannot sort out the problem with the Sparicotyle. Sorry to be so direct, but this is my idea. You need to reconfigure the production system. The current system, the current system is to produce in each farm continuously, and this is the big mistake. Not only for Sparicotyle, for many other diseases. So simply, the difference that instead of putting fish of different ages in the same farm, if you have 4 farms and you distribute the production and you put the fries in the different farms in different times, just with that you will have separate generations. Okay, this is more or less is in a scheme that I put as an example. You can produce exactly the same, but just changing the production samples. Basically, here in the first kind, you will harvest all year round in all farms, and in the right, you will harvest only during 3 months in each farm. Okay, but at the end, you will have the same amount of fish. Okay, all in, all out, and following basics. We cannot mix ages continuously. This is if you tell this to a terrestrial farmer, he will tell you that you are crazy trying to farm animals with that. So this is similar as I told you. But if you can include, for example, following, is just to have, let's say, 2-3 weeks without any sea bream in the farm, you can have the success. Other strategies: increase the pre-growth period in inland facilities. That this is connected with what I said. If we are able to produce bigger batches of juveniles that can be sent to the farm all at the same time, we'll be able to produce separately in batches, in separate batches. Okay, and I think this will have an immediate result on the treatments.
Cito.
2 minutes.
Okay.
Species rotation is another alternative. You can rotate, for example, because it's a species specific, sea bream, sea bass, nigger. You can rotate the species. If the market is willing to accept this product, why not? You can do that. It's an opportunity because it's not like Pastorella that affects all the species. Here, there's a single species affected. Okay, so another possibility. So the integrated management strategies are basically, in a nutshell, synchronic, extensive, integrated actions against the old one system that is asynchronic, individual, isolated actions. Treat pre-internal, external, post-internal, plus net change, cleaning, plus nutraceutic feeds using parasitic active diets or palliative diets. Remove the corpses daily as much as possible, and do the treatments in as much cages as possible and in a specific concentration area and in the shortest time. For that, you will require larger health teams with more ships and logistics. Unless you can have that, you cannot do this system. Again, no single magic solutions. Each place tailor-made species, integrative, holistic, synergic strategies. But last but not least, the process and success means proactive and integrative work between excellent colleagues working together on this multi-clamp troublemaker gillbugs. So this one is not my presentation. This one is a presentation that is based on the experiences with very nice colleagues from all around the Mediterranean. We have been working with them spontaneously in let's say a friendship. So basically what I can say that because I've been working with these absolutely fantastic people for many years. I'm getting older, and maybe this when one gets older have this kind of perspective. So but without these people it will be impossible to have at least this view. So thank you very much.
Mm-hmm. Okay, thank you very much, Sito. So we have well, several questions in the questions and answer, also two in the chat. So let's see what things we can discuss to start about. So just for clarifications, there are people asking about what does it mean intensity of infection and abundance. I don't know if Maria Letizia, or Andrea, or even Francesc will try to clarify this.
Very quickly, intensity is referred to the number of parasites of a specific species on the infected host. So if we examine, for example, 100 fish, and we find 10 fish with 10 parasites, we have a total of 100 parasites. We divide only for the infected fish, so 10, and we have an intensity, a mean intensity of 10. Or if we want, we can also have a range, minimum intensity and maximum intensity. In general, we use the average and the mean intensity. So the number of parasites for infected fish, in this case. Abundance is referred to the population. Yeah. So if we examine 100 fish, we find 100 parasites in 10 fish, but we did divide the 100 parasites for 100 fish. So the abundance is 1. So it is indicative of the distribution of the parasite in the population. For how is the correlations between these quantitative parameters and the pathology in the host or other specific features of the disease intensity is more important because it indicates the amount of parasites.
The burden.
Yes, the burden of parasites in the infected fish suffering so at a specific intensity. But abundance is very important because it gives an idea of the distribution in the population, and it is a really important ecological quantitative term. Mm-hmm. I was clear.
Okay, thank you. So there is also one participant that was asking questions related with epidemiology or the impact of the disease. That is also correlated with the benefits of the different treatments. So I don't know if maybe you can summarize in general terms what is the incidence at the farm level and the effects of the increase or worsening of the feed conversion ratio, reduction of growth, or even mortality. Although I know that there are big variations, but just to give us some light.
Okay.
Mm-hmm.
Also, Vito made a review on this, a recent review.
Yeah.
Summarizing. So, for example, prevalence is very variable. It go between 30 and 80%, could be very high. It depends on the environmental situation and the biomass also sometimes. There are many factors that influence the prevalence. And in the Mediterranean, Sparicotyle is endemic. So I think that where gilded sea bream is farmed, you have Sparicotyle, more or less, in sea cages mainly. And about the feed conversion rate, there are some data that are published, if I'm not wrong. For the feed conversion rate, with the fish with this parasite had an additional amount of 0.4. Is it right?
Yes, Rigos stated this following observations in different farms. Sito, do you agree?
Yeah, more or less. Maybe this percentage is in the worst case scenario.
Yeah.
Because, for example, talking about feed conversion rate, nowadays in, let's say, 99% of the farms has the parasite. So, normally talking about the normal feeds is with the parasite. Then the intensity changes a lot. But I agree with you that in case of high intensity, you can achieve these levels of reduction of increase of the feeding rate.
Which is a lot. Which is a lot, I think. No.
Yes, I remember that Rigos, the colleague from Greece who worked a lot on Sparicotyle, tried to define what means 0 plus 0.4. And he said that it could be around 50,000 tons of feed for production cycle, if I remember well.
More.
Yeah. But as the Sito was saying, so with a high prevalence of highly infected fish. So in this case, high intensity of infection in a high number of fish.
Okay. What about the reduction of growth or delay in the growth? Do you have some data?
I remember just the old data, and I cited the Faisal and Imam, who was the first. But it is a very old paper. But anyway, they investigated the condition factor, so the Fulton index. They found that.
I will say simply ask the farms. If they are willing to say something.
But it's important because they were the first to correlate the intensity of infection over 10 parasites for fish, which is adopted also like a threshold to start mitigate the problem.
I am completely sure that each farm knows exactly that. But the problem is that this is a very sensitive, and we have to be aware. This is a very sensitive information, and should be managed very carefully.
I don't remember other data. Maybe Sito knows because
I know the data from the farm, but obviously I will not say anything.
No, but it is right because it is so correlated to different factors of the host, of the environment,
and also secondary infection and
exactly.
And feed.
Weather conditions. Yes. It's impossible to just.
But it was the only data I remember was written about. Index.
Okay, and let's go a little bit further on the results that we are presenting here, because there are questions related maybe with the price of these functional diets. As always, there are questions about that. But related not only with the price, it is a question for Roberto. Are there, I don't know, legal restrictions for the use of the additives or that you are using in the diet that has been tested?
No, for example, for the use of Yeah, there are some legal restrictions, but yeah, I don't know exactly. So we did. This was a trial, so
Yeah. Okay. Well, just to remember participants that there are strict regulations for the use of additives.
yeah.
So all companies need to fulfill with these requirements. But in any case, we are talking about additives and functional diets, which for the use have much lower restrictions or no restrictions in comparison with medicaments or drugs. And when dealing with treating diseases, parasites, or whatever, the legal restrictions you might have for applying treatments are very important. So sometimes you might have legal restrictions to do prevention. In some places, it's not allowed to use formalin or other medicaments as prevention. And here we have a new tool. I don't know if maybe Matko, Roberto, or colleagues or Francesc would like to say something about this that is related with this integrative management approach that Cito was presented. No, I think that this kind of alternative is open new strategies complementary with the previous ones, and this is probably what is very, very worthy.
Just I want to say one thing, Bernardo, is that it's better do not mix the word treatment with prevention. Are completely different things. So when you treat is when you have a problem. If you prevent, you can prevent, for example, changing nets, but you cannot prevent using therapeutics. It's something that is very important if you want to keep the good prestige of our sector, because we are basically only doing treatments when it's necessary, not because there's a big confusion on that, and sometimes I think we must be very careful with the use of treatments in prevention.
Yeah, but no, but I was talking about functional feeds as a potential tool, maybe for low infections or even for prevention if your neighbor or neighboring cages or farms they have.
Yep.
I don't know if any one of you would like to say something more about this, maybe Matko or Andrea. Yeah.
Yes, I can talk about my experience with fight against Sparicotyle. I agree with Mr. Francesc Padrós. It's much important if we can do all in, all out, and keep different stages of fish. Keep the different stage of fish, same fish in enough distance cage to cage. And also when we have a lot of big concentration of fingerlings of sea bream in one farm, we have a bigger problem because we then can't prevent infection. The problem there is problem with regular change nets. Yes. And also or cleaning the nets, and we have in that time we have a big problem with Sparicotyle. Also we treat against Sparicotyle with formalin, but we can do very quickly because I think it's much important that we must treat the whole whole cage of fingerlings in short periods. But when we have a lot of cage, we can do that very quickly, and we have problems more and more because Sparicotyle from infected fish go on the clean fish, and we just have one circle with the parasite go from one cage to other cage. So now this year, also I noticed that last 2 years the Sparicotyle, I don't know, but he become resistance, or I don't know how to say on bath, because in the previous years we have one bath per cage during the first year of growth, but now last year and this year we must have 2, maybe 3 baths on same fish in first year of growth. Okay, that's my opinion from my experience.
If I can say something about
Please.
we followed the 2 trials together with Cromaris on the application of functional feeds. And I think that the strategic aspect of this administration is the timing, because they cannot kill the parasite, or in some cases could kill, but anyway, they can just prevent and mitigate. But it is not so less important, because we saw that starting from the introduction, from the moment of the introduction of fry from the hatchery, and generally the fry are negative, as Sito said, when they arrive from the hatcheries. And starting with the functional feed immediately before the starting of the infection, it is extremely important, especially when at the starting of the increasing of the temperature during winter, the changing of the net is associated. So then, okay, all the other things Sito and Matko say are fundamental, so like the following and so on. But the classes or the year classes and so on. But the administration of functional feed is important as prevention of the emergence of a clinical disease due to a high infection. So it does not avoid the infection, but just should mitigate the parasitic disease, maintaining low the quantitative parasitological indexes, and then associated also with a good management of cages and other husbandry aspects.
Okay. There is one comment in the questions and answer regarding the field test parameters, and they speak about the density of the fish, that saying that is maybe lower than in commercial farms, which is something normally very frequent, no? That normally on laboratory we use lower densities, not. But my question is not only about that. It's for Sito. I don't remember if in your review of different measures, integrative measures, if you have spoken about density as a potential measure. Lower in density can be also a strategy.
I think it's clear. The more fish that we put in the farm, the more opportunities has the Oncomycetidae to reach. And there is, let's say, as I told you, is the snowball effect. The more fish you have, the easier will be for the parasite to get attached and to stay in the farm. So it's density means also number of fish in the same space. And okay, so basically, the problem is the space. It's not only the fish in the same cage. These are all the fishes in the other cages. You can have a look on a syncytial way. It's not a single problem in the cage. It's the problem in the farm.
in the farm, but also very much related with the currents, no, with the renovation of water, all these
there are
all these questions.
yes, this can modulate the expression, but it's not the key. So I've seen problems in farms with high water currents, problems in farms with low currents. There is no single farm that is exactly the production system is exactly the same as the other. So you also have to take into account other aspects that can also affect the expression of the disease in the other farm. So I think it's difficult to say, okay, more water currents. For example, I can say that, for example, in Canary Islands, that are really huge water currents. I don't know. It's just if you fall down from from the cage, probably in 1 minute you will be 2 miles away from the farm. So maybe in this very rough scenario, even for Sparicotyle, there is some effects. But in normal water currents, half knot, 1.2 knots, I think it's can be an effect, but it's not the only one.
Okay, I don't know, Luca. Maybe you would like to point out something, because there are many comments on the chat and both on the questions and answers. I'm afraid that we are not going to be able to deal with all of them. But
I was just remarking what Letizia said about the timing, that was very important, that we start feeding the compound, the natural compound early, and that was probably a very key issue for the success of this prevention. That was, as already said, it was very interesting. And just a comment, if we saw, for example, what we mentioned about the FCR that can increase very high at 0.4%, it could be 30% of the biological FCR of CIHEAM, that will justify the cost of the additive if we consider the entire production cycle, especially that's I think it's also we've been talking about cost, but just considering the increasing of the FCR, that we can we have let's say there are on literature some example that is a very interesting issue about. So
well, something that maybe Roberto can add something is well, these functional feeds. I guess they look for, for improving the integrity of the mucosa of the fish, improving the fish health status, and other physiological characteristics of the fish that we are reading. That they are not good for only one disease. They are good in general, and also good for keeping a better welfare of the fish. So if I say that, is because I imagine that using these functional feeds, but just say that you might have also good effects for other diseases that normally are happening in at the farms. Because fish farmers know that, well, single disease is not the case. There are many diseases coming and going, and then this is a effect that is further than not dealing with a single disease. So maybe Roberto, you can say something about this, or maybe Sito.
Yes, for sure. The disease with the increasing of the parasites of the hills in farmed fish. So I think the solution is to increase the health status of the fish. So for sure, just to contrast the parasites, and I think this is the best solution for us. I think for the Mediterranean area in particular. I think.
Maybe Sito.
Well, more or less is a similar approach. I think it's the health, the nutraceutical or health feeds are important, are important, especially when you are wise enough to allocate the strategies in the right moment. Is the same. If you want to be on diet, you must put the diet on the best moment. It's not. I think it's you need to be efficient with the use of these tools, because nutraceutics are tools. So I think it doesn't mean that you will save the world with these diets. This is not the question. I think it's these diets, if they are well addressed to the right moments, can be very helpful, especially, for example, for juveniles, that if you don't have juveniles, you cannot harvest. This is the idea. So you are losing a lot. For example, in perform fish, what are we doing now is we are modeling economics of the disease. So maybe one of the candidates can be Sparicotyle. So it's a suggestion if you want to help us on that. But in this way, when you see the figures on how much do you save in terms of production or losses, etc., then you realize that it is worth to use these diets, because you are saving a lot. Sometimes the problem is that you don't see the figures, and without the figures for the farmer is something it's difficult to take a decision. So yeah. I think this kind of models, any kind, epidemiological or even the economical models of the disease, will be very helpful to take these kind of decisions.
Yeah, just to remember, because there are in the chat questions about the cost benefits of treatments or measures. Is that I mean, when dealing with this question of trying to look at the cost benefits, it's not only a question of money, it's also a question of sometimes of logistics, of things that you can do or things that you cannot do. And those are also things to be taken into account when you are looking for treating, controlling, or mitigating diseases. What things you can do easily or not so easily at the farm level is also very, very important. Just to remember that just for this kind of a study, these things will be also taken into account. And farmers, I'm sure that they do it.
Yeah. So if you are attentive to our webpage, Cure for Aqua, I think in few months you will have information about that. I'm sorry for advertisement.
No. We are here to disseminate information, and
we are paid for the European Commission.
We are paid for the same, and we should disseminate as much the knowledge generated by the different projects. Okay. Well, time is passing. I see that we have been followed by many attendees, but I see that the participation is dropping a little bit. We have overpassed the time that we predicted, or we scheduled for the workshop. So I don't know if Luca or any one of the panelists would like to summarize or make something.
I would like to first of all thank all the NewTechAqua partners and CIT, of course, to accept our invitation in joining this webinar. I think the integrative management in this very important issue will be the key of success for the future, and joint forces among partners, among projects, it's very important. And I also would like to thank the company, the farm company, and the industry for the key role in this project, because we can study in the laboratory this problem, but at the end, field trials are very difficult to perform, but are essential. So also thanks to the availability of the farms for to join this the innovation program project. Yes.
Thank you. I don't know if anyone more of the panelists would like to say something before we end. No, well, maybe just say goodbye.
Yeah, just say thanks and goodbye.
Participants can contact us when they want. They have contact details, so
we are here.
Yes.
Yeah, okay. And just to remember the audience that this webinar has been recorded, and in about 1 week or something like that, will be upload the recording of the webinar in the YouTube channel of NewTechAqua, where we are placing all the past webinars. Okay, so thank you very much
you.
to the panelists, to the attendees for following us today, and hopefully we see you in the next webinar of the project. Okay, so cheers.
Thank you very much.
Bye bye
Thank
to
you.
all.
See you
Thank you.
soon.
Thank you very much.
Cheers.
Bye.
Bye.
Bye.